Hi, today we're going to be looking at graphing translated functions. Let's see, how about we graph this function? Y equals, how about we do absolute value? So absolute value of x minus 3, and we can do plus 2. All right, let's start with the parent function. Our parent function, these are absolute value, so that means it's y equals absolute value of x. So we're going to first graph the parent function in green, and then we will move to the translated function and show you how nice these can be. So let's make ourselves a table of values. All right, that will look good. Okay. Right there. All right, we're going to have our x here and our y here. All right, values we're going to use are -2, -1, 0, 1, and 2. All right, now, absolute value of -2 is 2. So we plot the point -2, 2. So go left to -2 and up 2, put our dot. Then plug in -1. The absolute value of -1 is 1. So we have the point -1, 1. Put our dot. And then when we plug in 0, absolute value of 0 is 0. So we are right here. And then plugging in 1, absolute value of 1 is 1. So we go right 1, up 1. And then absolute value of 2 is 2. So we go right 2, up 2. Okay, and then we're going to connect our dots with a line. And the negative, then the negative direction. Oh, come on. There we have it. Okay. Now, let's take a look at our shift. First of all, this will move right 3 units. Remember, because if I took x minus 3 equal to 0, solved for x, I would get x equals 3. So it's 3 units in the positive direction. So shift, let me get my pencil. All right, we're going to shift or move right 3 and up 2. Because k is a positive 2. And so up 2 units. So we'll shift right 3 units and up 2 units. Now, we can do this in the table. We could also do it in the graph. In the graph, we would take each point and move it right 3, up 2. So if I take my vertex, I move it right 3 squares and up 2 squares. I'm right here. Then I take the point 1, 1, move it right 3 squares and up 2 squares. Take the point 2, 2, move it right 3 squares and up 3 squares. You're like, well, these are on that line. Yes, but if we keep going, this one here, negative 1, 1, move right 3, 1, 2, 3, and up 2, 1, 2. Now you see. Then our last one, right 3, up 2. I can connect the dots. Okay, that wasn't very straight. But you do get the idea. Okay, now, I could have done this graphically as well. See, if I took that x minus 3 equal to 0, add 3, I get x equals 3. What does that mean? It means you add 3 to every x coordinate. And this here, our k is plus 2, so you would add 2 to every y coordinate. So really what we have here for our x and y's, we take negative 2, add 3 to it, and we get 1. And then we add 2 to our y coordinates. 2 plus 2 is 4. The point 1, 4 right there. All right. Then we add 3 to negative 1, and we get 2. Add 2 to 1, and we get 3. The point 2, 3 is on this graph. Pretty cool, huh? So you can do this by adding to the coordinates. So we have 3, 2, and then 3 and 1 make 4. 4, and then 1 plus 2, 3. And then our last points, add 3 to x and 2 to y. So we get 5, 4. Pretty cool. So we can actually find new points, or we can just shift the points on the graph. Either way, they both work. And this is having some real fun with functions. Have a great day.